Okay, let's start. Experience the sky everywhere. Not that easy. And every time, like never before. That's a discovery. But what is the sky? Here, just beautiful image. La camera degli sposi, col cielo in una stanza, just to my famous artist. A room without sky is not a livable space. Our home is the cosmos, is not the box. But what is the sky? Is it the atmosphere? The atmosphere is just air, is the gas. The sky is the light from the sun that is diffused by the atmosphere. So the sky is a light, is indeed the light. And if we manage to reproduce the light of the sky, we reproduce the sky. But how? That's just an image. The light is not just what you get on the screen. It's some directionality, some phase, amplitude, spectrum. So how the light of the sky, so how the sky is created? Okay, so if you look at the medium, you see that the light, you see the light because it gets diffused by the medium. So the moon, there is no medium, so no scattering, you can see the light. But if in the medium you disperse fluctuation in density, like dispersing glass nanoparticles in that water, you will see that suddenly the high frequency components of the light get diffused as the air molecule fluctuation to the atmosphere, and the complementary component, which is the yellow, get transmitted and eventually shine. So these two components, diffused and transmitted light, makes the property of our diffuser, the sky, which is a dichroic diffuser, made of that case both the sun and the sunlight. Actually, in the atmosphere, there is an issue that the atmosphere is curved. So the light at noon makes 10 or 20 kilometers, and evening maybe 500. So that difference makes a lot of scattering in the early morning and much less in the noontime. So how can we reproduce the same effect? Artificial. So you can look at the equation of scattering. How to enhance? You can enhance the number of scattering elements. Yes, but how? You can enhance the diameter. Very big power, 6 power. But how to make that bigger? But you can also enhance the ratio between the refractive index of the particles and of the bending. So in that case, if we have high gap, there is a lot of scattering. So the light becomes reddish and a lot of blue light diffused. In contrast, if there is a match, the scattering is very low. So everybody will think how to make this effect of controlling the index mismatch. Comes to the idea of using the liquid crystal. Liquid crystals are indeed molecules that can be oriented, for example, by electric field. They can orient it, but they are also birefringent molecules. So they show different refractive index depending on the direction. So if we consider the two orientation with respect to the direction of the light, they can show quite different refractive index. And if one of the orientation gets matched with the refractive index of an embedding medium, for example, a polymer, we have the situation where in one case we have a lot of scattering match because these are red oriented, so all the mismatch is experienced and much less scattering when you have all them oriented. So that's known. Is the mechanism by which the PDLC polymeric dispersed liquid crystal are used to create the so-called smart glasses. They switch from opaque to transparent. But in this case, these droplets of liquid crystal in the medium have micrometer size. They look like the fog, like the mist, not like the clouds. How to make them so small, nanometer level, to create the radius? That's what we actually did. You see, this is the standard size, 10 micrometer. This is our technology that goes down to about 100 nanometers. And here you see there's a beautiful same picture of our liquid nanodiscs. The result is amazing. So you see here an experimental setup where the film is lit by white light. You see fiber probes the spectrum depending on angle. And because of that measurement, here you see it's really revolver, but a laser. So you can see the transmitted spectra or the scattered spectra, so the zero angle, in function of the voltage. So if you increase the voltage, the transmitted spectra goes from the very range, long wavelength, so right here on the red, and then goes more to flex, so to more brightness. And in contrast, the diffuse light, the voltage, goes from the coarse bluish, so it's more in the short wave, so here, but not very big blue. That increases the voltage, the scattering diminishes, of course, because we are matching, but the dependent goes very, very steep, and we have the deep. So by tuning the voltage, we can tune the transmitter and the scattering light so to mimic what happens in nature during the course of the day. So here is a high voltage. We are talking a few volts. So the light of the sun and the sky can be faithfully reproduced. This just to give a glimpse of how the property of the atmosphere, that the ray of the sun are changing the angle. We are not changing the angle of the light from moving the sun, but we are changing the direction of the molecules of the liquid crystal to obtain this change in the scattering cross-section. But let's assume that we now manage to reproduce. So here you see examples of real settings no time. So the projector is a bit weird, but now the point is how to reproduce the sun. Here you see a beautiful reconstruction of sunlight, visual sunlight, visual skylight, one of our products, which even produce the effect of the infinite depth of view. So the sun is very activity. But the equipment, so the lamp, let's call it, is 300 kilo and 8 cubic meter. So it's a little bit bulky guy. No? So and we managed to sell several of them. So it's a really fantastic. There are some crazy people exist on the market that build a car to be this. But now what you see here is a prototype where thickness of this prototype is of 2 millimeter light guide. So go back. Don't let me do so, because we end up in so this is a 2 millimeter light guide, and you see the infinite depth is created. So if you zoom and you get close, sun doesn't change size. So and then if you switch on, you see here scan on the focal length goes to see the light of the camera detaches. If you scan, so the motion parallax, so that the sun is producing your camera in your eye really move when you walk through the window as the real sun makes in a real world. This object, as I said, is only 2 millimeter. You see here this arrow. It's really quite here. Okay, what this arrow that you see are the direction of the two eyes. They are converging, if this seems diverging, but when you switch it on, the two eyes are directly parallel. And the reason is of this infinite depth, which is measured by different camera, measuring the verse of the two eyes, is because we have created a display that makes choose light and also highly directional light everywhere through this surface with the same angular spectrum. The two lenses of the two eyes, they are focusing this slowly weakly divergent light and creating the two spots, the two images on the two wavelengths. Because the lens will transform of the angular spectrum into positions. So the two retinas, two spots in the center of the two retina only if the two eyes are set parallel, because the field is uniform. So whenever you have a uniform field, you see the image at infinity. And so that's what happened when the problem, so So the work seems done. The problem is that this small skylight costs about €500,000 and has efficiency of few percent, so it's hopeful to create a possible problem. So what to do? The idea would be one, it's really forward. Let's assume that we have now a real device. These are LEDs focused by lenses of a millimeter size, and we would like to create the infinite sun and the sky effect. So if I put on top the Rayleigh scattering material, so I get the blue diffuse and the transmitter border. So that's clear, but still I don't see the sun. I see many different LEDs. How to homogenize, how to create optically a single sun image at infinity out of that device. So it could be a magic filter, no? That I can let in and that creates something like that. So to create out of this plurality of sources a single image of the sky and the sun. So the idea is to use the so-called fly eye condenser, which is nothing else than the double matrix of lenses, one with the focal length being focus one on the other. So this system here making about the devices is insensitive to the direction. So you see the light that comes from different direction that comes out all at the same feature. So the output of this filter is independent on the direction. So many LEDs shining light in many directions create the same output. So the lens guide creates this image here, which is actually the shape of the lens. So this is a single circle like the sun. One could apply this concept, but unfortunately, this device is sensitive for the crosstalk. So if the light comes at a large angle, it goes in the other channel, and so here the lenses are hexagonal. Instead of a single sun and hexagon, you see ghost images every. So this is impossible. It would be fantastic, but cannot be used in practice because there is no chance to cut the light crossing one channel to the other. What about if we use, this is the idea, the so-called faceplate. So the faceplates are those devices that you see here. I need probably you can still see me, and I can use the pointer. Okay. So the faceplate, you see this white block of fibers. They are so tiny they transmit the image without losing the resolution. Now, if you move it farther, you even see the desk below. These are these fibers, which are about 100 micron, just put together and squeeze thermally. The point is that even though these are hexagonal, actually Voronoi pattern, on average, they are round. So if you take the average of these shaped polygons, irregular polygons, you get this round shape. How they are made? You start from a cylinder, a polymer cylinder here. You create this spaghetti, so the fiber which is drawn. You cut them, then you glue together in a single block, and then this block is again put into the oven for several times until in every spaghetto there is inside all this large number of fibers, so that you are creating this at the end. And how to put the lenses? It's impossible. So if we cut this cluster of fiber, and instead of standard fiber, we create the green fiber, so graded index, so fiber that are having inscribed a gradient of refractive index. These behave like lenses, and so we can take the length of this tiny filter exactly as the focal length. This fiber, however, costs a fortune. So what we did is taking this cylinder made by like a matryoshka or different polymer with different index, and doing this process, like making the tagliatelle, so many times. Finally, you end up with the filter, and you can see here inscribed all this structure of different index material on every 100 micron. No? And this effect is incredible. So if you illuminate this filter, which you see here is about 1 millimeter, so what you see is perfectly round sun without any shade. So means that if you look through this filter, this is what you will see. And in fact, this is the what you can admire. So this is the original array of lenses. Now you will see entering the Rayleigh filter from the left that it comes in and create a blue scattering. But now how to merge, how to homogenize all these sources into a single sun. Let's get this, it's called magic filter or multi-step fiber filter, and here the homogenization application. This is a basic optical principle created by new micro-optics component, where every optics component is of 2/10 of micron, and what you see is not the effect of each lens, but it's the average effect. So it's statistical micro-optics that produce the image the first time in the regions. So the applications are enormous. So we transform spaces from here to here. So what you see here is, for example, you might know Auto Torino is one of the biggest dealers of 5 billion revenue, and as this here Bartellina is headquarters. So you see here a space of 300 square meter where the company has created a mensa for the employee, and the image of the sky is created, but also the sun. So if you walk through, you see that sun follows you at infinity, and all the light is completely without, and even those tiny downlight, they are carrying Rayleigh scattering. And that's you can see, because if you look at the shadow, for example, here in the bottom, every shadow is bluish, so illuminated by the sky. So if you have a real window here, the real sun will create a dark black shadow because the sun goes to the window, but the sky doesn't. It's too broad. So this is a super real installation. So the application, for example, in the healthcare industry, if you have a tumor and you lie here for 4 hours, you enter the gamma knife, so gamma ray are hitting your brain to burn maybe the tumor that could have inside. And suddenly the sky and the sun shines into that room, which is a bunker, of course, because this diagnostic and therapy equipment is an X-ray is always a -3 in the basement in the hospital. This is a very aggressive technology. People are very scared every time they use, and having the sky and the sun on top makes it eventually usable. Hospitality, like the hospital, no, is of course an important offices, because we are stressing the office space, and residential. So this is a house in London at -3 floor, and this is the bathroom, it's a 3 square meter bathroom, completely in a window glass, where you like in the paradise in Santorini. So to conclude, this is not just comfort. So there are several research made on humans at the psychological level, so comparing Qualux with standard, how people perceive the room with respect to positive, so active, accessible, lively, luxurious, or negative associations, so that Qualux is much more positive, much less negative. But not only about you perceive the room, as how people perceive themselves in the room with respect to fascination, performance, well-being, and so on. So, for example, performance. Are you feel eager to work? Yes, I do. And if time is going, I less and less. But Qualux, you are much less decaying in time. And actually, I was very lazy in preparing this presentation, because yesterday I was busy with the company board meeting, and I started at midnight in my office, and I ended up at 5 in the morning. I was perfectly awake, no any tiredness, because of under the Sicily sun. I can confirm personally. And the deactivation, so how you get tired after a while with Qualux is less. So 84% of statistically valuable data make a difference. How you feel claustrophobic, I must leave this room. And actually, the difference is huge. Now 84% again of significance. The anxiety. So in a windowless space, after 1 hour, people exhibit symptoms of anxiety, and switching it on, the score became back normal. And but that's all psychological. If we now go to physiological, measuring heart rate or rate variability on ancient inpatient psychiatric hospital, you see that the heart rate decreases at rest or under effort, but the variability increased up to 20%, which is the indicator on the Garmin that your stress is reduced. That's and there are many other measurements, but you see, for example, here in Japan, the onset of melatonin under coilux after a few days in the office space with respect to the normal. So the sleeping activity, it's important. No? And this is London Institute. They measure several things, including the alertness, which is increased, and the sleep duration, which is increased by 17 minutes after only 5 days of usage. No? This impact on sleep is very important. And in the last data concern the usage of coilux for therapy, not just for the comfort and well-being, but for treatment. Like in San Raffaele Hospital, they start using together with drugs to reduce the recovery from severe depression, this kind of suicide. In that case, they noticed that the patients that early in the morning when wake up under coilux, they sleep better. No? And they investigate more. And for example, they have measured the first time the impact of adjunct bright light therapy on subjective sleep quality. So not only the people sleep longer, but when they wake up, they feel rested. So that's the first time shown in the literature that the bright light can be used to make really the people wake up rested. No? And that, of course, all the study with comparison groups and so on and so forth, I don't go in detail now. Another, even change the architecture of sleeping, so waking up the people during the night so that you can interrupt and control the different phases. And they managed to control these phases N3, which is related to depression. So they were able to control the reduction of depression symptoms by playing with coilux in the control of the phases. And finally, irritability. So depressed patients, they are severely irritable to irritable people, and this they are crazy, no? And they managed to reduce by 30% of irritability, and many other things. So here, so when they say everywhere, you know what I think, no? Because everywhere means really everywhere. And where is the place when we should make the sky? There is no sky; it's in space. So here I was just in the last week in the Lario Center, so the space center in Lario, NASA and other SpaceX or other astronauts. Indeed, people going to space are missing the sky. So, and my dream is to bring the sky and bring it out of Earth, the atmosphere, the moon, of Mars in long travels, because that will make the difference. So here is the place where 2001 Space Odyssey, Star Wars, were shooting, and all people know Como Lake because of those following all of its story. This is a story we have to tell. And also I think this Volta event could be the case, not to bring the sky out of the Earth. Thank you.